Okay, so we're going to talk about two-way frequency tables. What you're going to learn is how to read two-way frequency tables, how to find probabilities using two-way frequency tables, and what it means when events are independent, and what is conditional probability. Okay, this is an example of a two-way frequency table where they give you categories on one side compared to the categories on the other side, and you have some overlap in events here. Normally there's a total column. If there's not a total column, then I want you to draw that total column on so that you can use that information to help you solve the problems that you're going to be asked. Okay, and the simple way to get the total columns is you just add this up. So this is telling you that there's 225 people that have been smoking for 10 years. And then of the people that have not been a smoker, there are 275. And then here are the ones that have not developed lung cancer. So you get 2 plus 2 is 4. 72, and then 25 plus 5 is 28. Then you get 500 people in all. So your total sample size is 500. Now to help us answer this question, we'll go ahead and identify us some independent events, which normally will be given to you when the question is asked, or will be defined for you. Is a person is a smoker, that's S, and L is the person has been developing lung cancer. So here it says find the probability of a person being a smoker and write the question in set notation. So the probability of being a smoker, that's your set notation, and that equals, okay, so let's go to where the people have been a smoker at. So that's 225 divided by 500 people in all. So it's what you want, that's probability, what you want, over how many you have in all. So 225 divided into 500 equals 45%. The next question says find the probability of a person that has developed lung cancer and write the question in set notation. So the probability of someone that has developed lung cancer, that's your set notation. We're going to go over here and look up those that has developed lung cancer, which is going to be 28 over the total of 500 people. So we're going to put that in the calculator. 28 divided into 500 equals 6%, round to the nearest 100. So I'm going to say 0.06 or 6%. It says find the probability of a person developing lung cancer and a person is a smoker and write the question in set notation. So the probability of lung cancer and, that's and there, yep, and the person is a smoker. So you have a formula for that. That formula is, and it's on your formula sheet. You don't have to memorize it. You just have to know when you're using and. So I'm going to write it a little smaller here. Probability of lung cancer and is a smoker. That formula is the probability of L times the probability of S when those events are independent, and these are in this case. So we're going to take the probability of S and L, which we already have. So L is 0.6 multiplied by 0.45. And if you didn't have these decimals already, you go ahead and calculate these two individually and then multiply them by each other. So 0.06 times 0.45 equals 0.03 or 3%. Now it says find the probability of a person developing lung cancer or a person being a smoker and write the question in set notation. So the probability of having lung cancer, or, which the or is that the union symbol, the person being a smoker. Now there is a formula for this, and it is also on your formula sheet. The probability of the first event plus the probability of the second event minus the probability of both events happening together, and that would be an and. So here we already calculate this. The probability of getting lung cancer, of developing lung cancer, is 0.06. The probability of a person being a smoker is 0.45, minus the probability of lung cancer and a smoker, which we already calculated that too, which is going to be 0.03. Go ahead and do the math here. And if you didn't have those decimals, then you do those fractions. And you and then you do the math. And this is going to be 0.48 or 48%. Okay? So we're done with that one. I'm going to go to the next page and use the same information. These questions are continued. So this is 272, 28. I'm just getting my total boxes on this one too. If you're given a two-way frequency table and you're not given totals, then you put the totals there. 225, 275, and it's 500 in all. Remember, this spot right here is your total amount. That's going to help you get your probabilities. It says find the probability of a person not developing lung cancer. So the probability of not getting lung cancer or has not been a smoker, and the word student shouldn't be here. So these are called complements, and we're going to do them the same way. So the formula works the same. So probability of complement of L plus the probability of the complement of S minus the probability of the complement of L and the complement of S. Okay, so how do you get complements? Well, the way you get complements is you find the original probability and you subtract it from 1. So we already know the probability of a person getting lung cancer. And the probability of a person developing lung cancer is 6%. So I'm going to come here and do 1 minus 0.06. That's that part. Keep it together. Plus 1 minus, what's the probability of a person getting lung cancer? Then we already, probability of a person being a smoker. We already have that. That's 0.45. Or you can calculate it the way you already done with the other one. And then we're going to minus it from we're going to take that and minus it. And since these are complements, 1 minus the probability of them having lung cancer and is a smoker, so we already calculated that to be 0.03. So we're going to say minus 0.03, and let's see what we get. So we're going to grab our calculator and we're going to type all of this in. 1 minus 0.06 plus 1 minus 0.45 minus 1 minus 0.03. So when you get your complements, you go in and you do the 1 minus them, and you'll get 1 minus the original probability, and you'll get the complement. And when you add the original probability with the complementary probability, then you get you should get 1. So plus 0.52 or 52%. So the next one says find the probability of a person having lung cancer given that the person is a smoker, and write the question in set notation. So this question is asking me the probability of a person having lung cancer. So the probability of getting lung cancer given that the person is a smoker. This is called conditional probability. This is conditional probability, and you have a formula on your formula sheet, and it is the probability of the first event and the second event over the probability of the second event. So here we just need the probability of having lung cancer and a smoker over the probability of being a smoker. So I'm going to go look at the other probabilities because we already calculated that. The probability of having lung cancer and a smoker is 0.03 over the probability of being a smoker. Oops, wrong way. Probability of being a smoker, we already calculated that too, which is right here. So we're going to go 0.45. And the way you can calculate this is just go back, break this formula down, and go back in, and this formula is on your formula sheet too, and go back in and use your table to get what you need. So 0.03 divided by 0.45 equals 0.67. Not 67, 0.06. So 0.607 or 7%. Okay, the next one says, find the probability of a person being a smoker given that the person has not developed lung cancer, and write the question in set notation. So find the probability of a person being a smoker and the person has not developed lung cancer. Okay, so now we need to work this formula, and it works the same way as the other one. So you get the probability of the person being a smoker and them not having lung cancer over the probability of not having lung cancer. Okay, so if we look here, the probability of a person being a smoker and not having lung cancer, I'm going to have to go and break that down some more, because we don't have one for this one. We have the ones where it's 2 complements. So I got to go and do some math for that. So if I break the and one down at the top, I do the probability of smoking times the probability of not having lung cancer over the probability. This is broken down to this, and I just bring the bottom one down. You have the another version of this on your formula sheet. This and this are equal. So the probability of being a smoker, we already know. The probability of being a smoker is 0.45. And if you need to go back and calculate that, then do so. So I'm going to put 0.45 multiplied by the probability of not having lung cancer. And we already calculated that right here. The probability of not having lung cancer, that was 1 minus 0.45, because the probability of having lung cancer is 45%. So the probability of not having lung cancer is 0.55%, or 0.55, not 0.55%, just 0.55, over the probability of having lung cancer. And we just did that. So let's do the math for that. So we get alpha y equals, enter that, 0.545 times 0.55 over 0.55, over 0.55 equals 0.45. So the probability of this event happening, that you have a person that has is a smoker given that they have lung cancer, is going to be 0.45 or 45%. And I believe that was the last one. Yep. So you go through, knock out the rest of these problems. Take your time with them and calculate all your probabilities, and I'll see you later. Bye.